record button, so we'll start. Let's take a look at the agenda today. So it's Tuesday, first week of the fourth week of the class, which is good. So just a couple of announcements to kind of make. We'll go through this agenda, then I have a couple of announcements. One is about the February 24th class, which is next Tuesday, and then some other things about the videos. Hopefully you all got your the assignments returned to you. I wrote up reasonably extensive notes, but if you have any questions, there are a couple of places where I had some asks for you to call me if you had further questions, and hopefully that was those notes will be helpful to you. Then we want to go through some questions about the last and recap the last lecture. If you have any questions, I'm going to do a quick recap of what we covered last time. And then we will finish up in the week 3. We won't do the whole sections because those are covered very, very completely in the videos. But we'll cover sort of live a couple of the examples and the basic guts and the thinking of that whole section on what's called capability. And then I want to briefly cover signal level, which is capability dressed up in its Halloween costume. It's really the same thing, but I'm not going to blame myself, but I blame people like me, Six Sigma professionals from 10, 15, 20 years ago who invented this metric, and all it really does is confuse. But now it's out there, and so as black belts, you need to know it. And I won't say all it does is confuse. It has some positive points as well. But we'll talk through the mechanics of the calculation, hopefully give you a flavor where people can go awry or get carried away with it. And then what I want to do is I want to jump back into the week 4 metrics. Now in week 3 we were doing a lot of calculations and statistics and stuff like that. In week 4, the beginning of it's going to be sort of lean and team tools. That's today. We'll cover most of that today. I want to be very brief though, and really just cover the lean nuts and bolts tools and the team tools. Now, I don't want to. I think that you'll find that these are very straightforward, but I don't want you to think that just because we're covering them quickly, it doesn't mean they're very valuable. They are. They just tend to be the things that people understand pretty quickly, so we're going to cover them quickly. So if you have any sort of questions or whatever on them, please do not hesitate to ask. So anyway, so that's our agenda for today, so let me end the suspense here. I actually have to show up in Washington on the 24th, and I'm briefing CNN of all things, and so I won't be able to run the class on next Tuesday. So my plan would be to have either a makeup or just an extension, if that works for everybody, whatever is the easiest. But I'll send out an email to just kind of get your feeling on how we want to handle that one. Even if we can have some people show up or an extra session, whatever it takes to make sure that we cover that material. So that's next week. But Friday will be fine. So I'll be back on Friday, and we'll have the class as usual. I also wanted to make sure. Oops, I have to go to here, I guess. I also wanted to make sure that you know where the videos are. So hold on, I'm just going to. I'll spare you the whole login process that I've got, and I'll try to spare myself the privacy here. So just keep in mind that the videos are all posted, and they're not just for the lectures that we have. From here on in, all of the sections are covered. So all the sections in week 3, if you want to go back through any of those data analysis examples, if you want to go back and and look at the control chart stuff. That's all covered. Now you can see they have varying times. I try to go quickly where I can. Data analysis examples is a long section, so it takes about an hour to go through it. But you can obviously fast forward it or find wherever. You may find that in some of these cases, particularly, for example, when you, instead of reading through probability distributions, it may help to actually just watch the video as it goes through, and that covers a lot of things as well. And same with Intro to Stat Inference. Some of these are assigned, most of them are not in the assignment that you get. And this is going to be true of week 4, week 5, week 6, whatever. So you'll have all those to go back and look through as we move on with the course, as well as the lectures that we have. So if there was something specifically covered in a lecture, you had a question or something like that, you can obviously go back and look at those. Hopefully that makes sense to everybody. Okay, I'm going back. And I think that's about it. You all got your assignments back, so I think I didn't get any bounces on the email, so I think we're set on that one. So let's kind of move into the questions. So what questions do you have, either about the assignments, the ones that you currently have, even the previous one, or the lecture that we had on Friday? What questions do you have? Okay, so we'll get going on the capability, but I do just want to remind you that just like with I know some of you did the net present value one. Most of you did the net present value one directly in that Excel file. That's exactly the way to do the assignment when you're doing the data analysis stuff. Very easy to, or that's the easiest way to do. I won't say it's very easy. It won't be. Some people find it difficult, but I think if you think just pretty straightforwardly on the whole. First, I draw the box. Then I write what's my input, what's my output, right? And I do it specifically for the problem. And I look at, this is my y and this is my x, and I look at whether it's a num or a cat. And then I do the analysis by essentially pressing the button and wading through it in Excel stats. That ought to do it for you. Okay? That ought to be the guide for you. Remember, if you have any frustration in Excel stats, don't hesitate to call. All right? It's a free utility, and sometimes it acts that way. Okay. Okay, so let's get back to, let's go to, oops, should have this open. I'll rectify that situation right away. Okay, so let's go into week 3, and we're going to start with a section on capability. Okay, so that is on one. Oh goodness gracious! I said 102, but that's not right.
Process capability is on 90.
Yes, that's the one we want. Page 90. Thank you. Appreciate that. So we'll start the one on 90. And I'm not going to go through all of these slides by any means, but we'll go through the examples that are in here. And I think the key thing to think about as we're doing this, remember last lecture we covered this whole, whoops, doesn't help writing with a white pen on white. I said it doesn't help writing with a white pen on white. There we go. Okay. So remember, this is part of baselining, and here we've got our customer, right? Ooh, that's a terrible drawing of the customer. There, that's not so bad. Okay, and we're trying to get the voice of the customer, and we're trying to get the voice of the process, and we're connecting it with our key output variable, right? Our y or our KOV. That's what we're trying to baseline. When we do that, we learned this two-pronged method. The first was we're going to look at the voice of the process, and here we're going to look at a control chart. Last time we learned a type of control chart. Does anybody remember what that was called? Which type of control chart that was called? Started with...
The
go ahead.
time scale?
Go ahead. I'm sorry.
Time scale control?
Yeah, there's always a time scale. So a time. Let's go back to the basics here. So a control chart always shows my y over time. Okay, that's what it always shows, and it has these two red lines on it. That, if you recall, does anybody recall what those two red lines were?
Those are the outer control limits, upper and lower.
Those are the UCL, the upper control limit and the lower control limit. Steve, as you said, that's right. Does anybody remember where they were placed?
3 plus minus.
You got it.
Yeah.
You got it. So this is at plus, it's at the mean plus 3 sigma, right? And this is at the mean minus 3 sigma. Remember that? Okay. All right, good. So that's what a control chart is. Those red lines there show me when a process is in control or when it's got what we called special cause. So if there's a point that's somewhere like here or something like that, the idea would be we investigate this first before we do anything else, right? The idea is first you investigate to see if a process is in control. That gives you the biggest bang for the buck. Looking for outliers, very often the biggest bang for the buck. If you have a process that's largely in control, however, and then we've got a second part to this, because this really just tells me what, last time we talked about how this tells me the voice of the process. Now the reason it tells the voice of the process is these red lines, they don't come from your manager, they don't come from your customer, they come from the process. You're getting them from the data itself. So when we do these 3 sigma calculations in the mean calculation, that's coming from the data that you've got. So your process data is going to dictate how your process is performing. That makes a lot of sense, right? The second part, but it's not enough. So just because a process is in control does not mean that it's good. It could be a consistently bad process, right? All it really says is that it's fairly consistent. So we also want to bring in what we call the voice of the customer, and for this we call, and sometimes we call this voice of the process stability. We're assessing the stability of a process. Remember that term that we used? So all of that kind of is voice of the process. Control chart, stability, looking at something over time. That's what we're trying to do. We're trying to assess, is it stable or is it not? The second piece of it is what's called the voice of customer, which is also capability, and that's where this comes in. And we said last time it's the percentage. We could say we could make it flowery language, but it's either it's the percentage good. Okay, let's just leave it at that. But of course, we know if we have the percentage that's good, we also have the percentage that's bad, right? I mean, that's not too hard. I mean, if we know that the percentage good out of our process is 85%, what's our percentage bad? Anybody?
15.
15. Yeah, 15. It's not rocket surgery there. So that's what we're trying to do in this section. So functionally, what we can do is there's a couple of different things that we can do. Okay, but here's how we want to conceptually think of what capability is. Okay, we take the histogram that we make from our key output variable, our y. So notice we're changing where it is. Got it? So now this is our y here as opposed to up and down on the vertical. Now it's horizontal. And here, this is the histogram. So this is showing how it's accumulating or whatever. And now, and I'm going to purposely draw a different color here. And now we draw a line, and this is our spec. Now notice this is different from the red line, and that's why I drew it as blue. This is what the customer tells us, or what our manager tells us, or what our sponsor tells us. So this is our SLA, or our performance guarantee. This is what it is, okay? Hopefully that makes sense to everybody. So, for example, if we were looking at turnaround time for an invoice, Gina, what might that be, our spec? It could be anything, right? I mean, you can just throw out a number. we want our customers to turn around our invoices in, or we want to turn
2 days.
Yeah, there you go. Or we want to internally process this in 2 days or 3 days or whatever. This doesn't come from the data. This comes from, somebody's opinion of how good it should be. Hopefully that makes sense to everybody. And then the percent good is just all of this stuff right here. It's that simple. That tells me the percent good. So that's the 1-2 punch in this section. Is in the section previously, we talked about stability, and then we can talk about capability, which says how good a process is. So if a process is stable and it's good, that's where we want to be. If it's unstable, we need to get it to be stable first, but stable isn't enough. We could have stable and consistently bad too, right? A high percentage of bad. Make sense to everybody? Okay, good. All right, so this is all, if it were that simple, the section would be over and I would quit my yak and we'd go on to the next one. And it sort of is that simple, but it's a little bit more difficult. It's great if we can count this stuff. So there's two situations. Number one, if we have a lot of data, we just count percent good. And you know what? That might cover 80% of the times that you're looking at it. If you've got a lot of data, just go ahead and count the percent good, and we're done. Very, very simple. If we don't have a lot of data, we need to model. Not lots of data. It's terrible English. Then we've got to do something else. Okay. And I'll tell you what that something else is. But let's just go ahead and do the first part. And I want to show you how to do it in Excel stats. Okay? So to do that, let's go to the example that's given. And like I said, you can read through this, and it's more flowery language. But let's go ahead and do the example that is on this one right here. Okay. So here we have a Six Sigma team that we're pulling all of its collection. This is a collections project. So they're looking at times to collect invoices. And the team has a specification that collections were supposed to be less than 20 days. Let's estimate what the current process capability is. Okay, let's not worry about the stability of this process. We're just going to look at the capability. So hopefully that makes sense. Again, let's just to be sort of anal retentive about this one, let's draw our process box. This is time to collect invoices, and we have a spec of 20 days. Now I'm guessing that this is also a n variable, a numerical variable, but the acid test is when we look at it. All good? Okay. No news is good news. Okay, let's go to this one. And there it is, invoices. We'll open it up. Okay, I'm going to try and put some people on the spot here for just a second. But let's see. John, I'm going to put you on the spot. So, what sort of analysis do you think we should be doing here?
Looks like num.
You got it. One num, right?
Yeah.
Okay, you got it. I put you on the spot, but not too bad, I hope. Okay.
No.
So let's go ahead and click on one num analysis. And that's the beauty of it, is we'll be able to do the capability right away. So the first question is kind of going back to our situation. I said we have two situations. One is where we have a lot of data. One is where we don't. What situation do we think we have right here? Any guesses?
Lot.
Looks like we have a lot of yeah. It looks like we have a lot of data. This is a pretty thick plot. The plot thickens here, and I know. I'm sorry, I couldn't help it. I try to throw those in just to see if you're still breathing, guys. But 10,000 you can look at up here. There's 10,000, and if we take a look at the histogram, we could just eyeball this, right? We can just eyeball it and say, it looks like maybe, I don't know, what would you say? What percent is bigger than 20 days? Just a guess? Anybody? No wrong answers here. Go ahead.
20%.
What's that?
About 20%. About 20% maybe.
20%, that's it? No, I'm kidding. Okay, it seems like a pretty good guess. Sorry. I just said no wrong answers, so I was going to pretend that was a wrong answer. But you notice how 20% bad, that doesn't sound like a great process, right? And can you imagine, though, somebody reporting, oh, yeah, well, we turned things around in 15 days, because that's the average amount of time that it's turned around. I can certainly see people doing that. Okay, well, let's take a look and see how we can get this a little more exactly calculated. So if we go to the Summaries tab, remember this one, and what I'm going to do is, first of all, I'm going to make this a percentage. So I click on that. So now I've got percentages there. And I'm going to show the values. I'm going to take off one decimal point. This makes it easier. And now I could add up all these boxes, but boy, that seems like a lot of work. And by the way, I'm not capturing everything above, what was the spec? 20? I'm not capturing everything above 20. So maybe what I want to do is I want to go from, something where it's going to be an even multiple of 20, like, I don't know, 100 and, that didn't work, but how about this? All right, well, now I could do it. I could certainly add all that up, and that would give me the capability. But I could also, let's see, what if I did just 6? Yeah, look at that. That helps a lot. And so right away I can say, aha, well, I don't know, percent good I still have to do some work, but I can tell, I'm sorry, percent bad I still have to do some work, but percent good is pretty easy. I just have to look at this right here. I'm going to mark as green. Oh, great, I marked everything green. And the green stuff is 74.1%. Let's just make it easy on me. 74%. So that means that what percent good is it? 26% good. And I'm done. That's my capability. I don't have to go any further. And so if I had, is my process stable? I made a comment about that. I can say what percent good it is and move on. And I'm done. I'm done with baselining my my variable. Hopefully that makes some sense. What questions do you have on this one? Okay. Pretty straightforward. All we're doing is we're counting good and bad. All right. So now we're going to do something that's a little bit more difficult. And I don't usually cover this in, I cover it a little bit in green belt, but this is definitely sort of moving into black belt. And what happens when you don't have a lot of data? So basically, did I give my rule of thumb last time on how many data points we want to have for I said a, quote, good histogram? How many data points are we looking for there? It's just a rule.
Said about 15, you said.
About 50. You want about 50 points to have a good histogram where it's going to be stable. So that's going to kind of maybe give me an idea of whether I have a lot of data or not. But you have to use your judgment on this one, okay? Sometimes 50 is not going to be anywhere near enough. Sometimes it's going to be fine. But the bottom line is when you don't have a lot of data, here's what we're going to do. So when we don't have a lot of data, so this is the situation. Don't have a lot of data. Don't have a heap of data. Okay. what we do is we make the histogram, which we should be doing anyway. Okay, and let's suppose the histogram looks like this. Okay, we make the histogram, and then what we're going to do is we're going to, step 2 is draw a curve approximating histogram. What does that mean? Okay, what that means is literally this. I take my pen and I kind of make something that traces out what this histogram looks like. Okay. Step 3, I look in catalog, and today we're going to have a catalog of one item, and it's going to be the bell curve. All right, so we're going to do everything with the bell curve today, and that covers a surprisingly large amount of ground. But there's a couple of other things I want to briefly discuss. One is something called a log normal. The second is called a exponential. And a third is called a Weibel. I don't know if there's a second L. I can never remember that. And basically, they just have different shapes. Okay? Like, for example, a bell curve looks like this. A log normal looks like this. An exponential looks like this. It's even more extreme than that. And a Weibel is fairly flexible. A Weibel you use in reliability and life studies. It's used extensively in that. So whenever you hear anybody talking about reliability or things like that, they're probably somebody somewhere is going to be using a Weibel distribution to do this. But anyway, today we're going to do this and this one only. So we look in a catalog and we pick a distribution. Now there's lots of discussion on all sorts of boards about, quote, what's the best and how do you pick the best one. I'll tell you the best way to do it, since you don't have a lot of data, right, is to pick something that looks like it fits pretty well. It's really that simple. Make the picture, draw the fit in your mind, and or in fact, and then pick from the catalog on what you think looks best. That's going to be best. In the cases where they all work, guess what? You're picking among things that all work pretty well. You're going to get a number that's pretty decent. Remember, we don't have a lot of data, so we're just trying to make our best guess and do a pretty good job of it. And then the fourth thing is we look up parameters. And I'll tell you what that is. That's basically the mean and the standard deviation. And then we finally calculate probability. Oops, I used the wrong word, but it's actually the same, capability. All right, so that's the way it works. And so let's go ahead and do an example. We'll do two examples, and I think you'll see that even though it might look like there's a lot of stuff here, it's actually not that difficult. Okay? And remember, if you have a lot of data, and that's going to cover you most of the time, just go ahead and count, which you probably should do anyway. Okay. So let's go ahead and what I want to do is I want to do the example that's on 114, which is on emails. Whoops. Let's see. This is the, oh yeah, I just to mention that in the book there's the old calculation using what's called z-values. Nobody ever uses those anymore. I would be remiss to not tell you about them though. So there it is in the book. If you want to look up how to do it old school, there it is. Okay, but we're going to do emails, and so I envisioned that this was this is a situation where for 60 days I've counted the number of emails I received, and I don't like to get a ton of emails. That probably means I'm getting too much spam. So I want to count a bad day of any day that I get more than 40 emails. Okay? Oops. I was a little bit cavalier there. Any day I get 40 or more emails. Okay? So sometimes you have to be very careful about how you define it. Is it 40 or more, or is it more than 40? More than 40 would 41 would be a bad day, but 40 would be an okay day. 40 or more, 40 would be bad also. Hopefully that makes sense to everybody. All right, let's go to page 114, and because this kind of details how to do it in Excel stats. So we're going to be covering what's on 114 and 115, but I want to show you how it's done. Okay, so let's start out from the start. So here's my data, and I said the first thing to do is plot it. So we're going to do that. Okay, so if I draw my box, and I'm going to try and live up to this. If I draw my box, and this is number of emails. Tammy, what kind of data do I have here?
Num?
One, that's a num. You got it. And so the analysis I'm going to do is
One num.
one num. See how easy that is? You got it. All right. Emails. One num. Just like Tammy said. Okay, so I've got 60 of them. Maybe that's a lot. Maybe it's not. But let's go through the motions anyway. Okay. So the first thing is I'm going to count, even though I said, but we'll show you how to do the other. Let's just go ahead and count doing our old method. And remember, that's on the Summaries tab. I want to do percentage, show values. I'm just going to go to a single decimal point to make it easy for me. And I said 40 or more. Okay, so how about this? How about if I go from 0 to 60, and I make, whoop, not 6, 60, and I do 3 boxes. Okay, so that says 7% of my days I get 40 or more emails. Okay? That's just straight counting. Now let's see if we can, when I go to here and I do, let's put up a reasonable number of boxes. It certainly looks like it might be a bell curve on this one. If I were going to fit one of my distributions, this probably looks better than, something that looks like this or this. To me, this is a pretty good fit. It's not perfect, but it's not bad. So I'm going to go ahead and pick the normal distribution as my fit. Okay? All right. Now I'm going to remember before, we'll come back here, but I'm going to remember these two values, the mean and the standard deviation, 24.9 and 9.656. Okay, let's see if I can remember that one. All right. But you don't have to. We'll be able to come back here. Okay. So here's how we're going to do this. Here's how we're going to fit the curve and then count in Excel statistics. So we already did our histogram. We fit the curve. And now what we're going to do is we're going to do the calculation. We're going to pick a curve. We pick the normal. And now we're going to do this in Excel statistics. So the place to do this in Excel statistics is right here in PDF. And it kind of works just like the control chart did before. Remember, the control chart wasn't quite the, oh, you select the data and then you click on the function. It needed a little more love. The PDF doesn't need quite that much love to make it work, but it does open up separately, so you don't have to pick any data. All right, so here it is, and you can see there's lots of different distributions. Like, for example, if I pick the exponential, let's take a look at that just for a quick look. There's my exponential. See, I told you it looked like that. And as I change my failure rate, it's often used in failures as well. If I change my failure rate, let's change it. We'll be able to see the graph change. It won't be that dramatic, big deal. Yeah, big deal. Didn't look like much happened. It just changed the scale there. Okay. Anyway, we don't want this one. We want to go back to our normal distribution. And let's take a look at our normal distribution. So you can either just click on the tab, below, or you can use that little radio button, which is kind of cute. Okay, so let's take a look at what's going on here. This is our normal distribution, or bell curve. Statisticians unfortunately named it normal distribution. It's a terrible name. I wish they would have stuck the bell curve, but that's what it is. And it's got two parameters, the mean and the standard deviation. And if we change the mean or the standard deviation, the picture is going to change. So for example, if I change the mean from say 10 to 20, what's going to what happens? Well, it just shifts it on down the road here. You see it went from being centered on 10 to being centered on 20, and I can prove that by just moving it up from, say, make the left, let's just make the right 40. There we go, and it just moved it down the road. The standard deviation, on the other hand, widens it or narrows it. So if I make a big standard deviation like 5, it's going to widen it up. If I make a skinny one like, say, 0.5, it's going to make it real skinny. Okay? So that's what that does. All right, back to the regularly scheduled program. Now, all we need to do is, if we plug in our values here, this is the normal curve that best fits our histogram that we have right here. Okay, so if I plug in this 24.9 and 9.65630, I don't have to be that precise, but I'm going to just go ahead and copy those and paste them. I'll paste them over here for, great. Paste values. There we go. I'll paste them over there for reasons that I'll make clear in just a second. Anytime there's blue in Excel stats, it means that you can input things and you can change them if you want, which is kind of cool. All right, so there's my new mean, and 9.656, close enough for jazz. 9.656. If I put that in, that's my standard deviation, and that is indeed my normal distribution. I'm going to make that a little bit bigger so we can see it all. So this is the distribution of emails that I get. Now notice some of it is unrealistic, right? So it fits negative values. I'm never going to get negative emails, so that doesn't make any sense. Okay, but in general, it's not a bad fit, and we're going to go ahead and calculate the capability now. All right, now the capability, pretty simple. All we have to do is put in what our specification is right there, and then it gives us the answer. So this tells me the probability that that I have that's to the left-hand side, and this tells me the probability that is to the right-hand side, the probability that my value is greater than that. It wasn't 20, was it? It was 40. That 40 was my specification for this. I was wondering why I had a crazy answer. And if you want to see that, you can go ahead and click on Shade the Cumulative Probability. And this tells me, essentially, this is shading everything that's less than it. So this says 94% of my days, this is how I would put out my capability. This is a process that's 94% of the time I have a good day, 40 or less emails. 6% of the time I have a bad day, 40 or more emails. And in this case, it matches very close with the count. Doesn't always have to match close with the count, but that's it. So that's it. So now you can cut and paste this or do whatever you want with it, but we're done. The capability here is 94% good, 6% bad. Make sense? Questions on this one? We'll go back to 114, which is, 114. Okay, so all of that is summarized right on here, and so hopefully that's pretty good. By the way, all the probability distributions work exactly the same way. You put in your parameters, and then you put in your value of the variable that you care about, a spec, and you look how much is greater, how much is less. Okay. All right. We're not going to cover the examples in Minitab because that uses something called a probability plot. I do want to also cover something called two-sided capability. So the example that I'm going to give here is, now this happens a lot in manufacturing, it happens less in transactions. So a two-sided capability, like let me give you an example of something that's probably not a two-sided capability, it's probably a one-sided. the time that it takes to make a collection. I don't really care how quickly I get the collection in. Like if somebody says, I got it in, if we got somebody's money in 2 days, that's probably good. And if you got it in 1 day, it's probably even better. But we might not want it to ever be worse than, say, 20 or 30 or 60 days. Okay, whatever that specification is. However, in manufacturing, sometimes, and in many processes, sometimes you have things that are too big, sometimes you have things that are too small. For example, if I were manufacturing, I don't know, say a pen, I wouldn't want that pen to be too long, and I also wouldn't want it, because then it wouldn't fit in the package, but I wouldn't want it to be too short either. Or if I'm making television tubes, I wouldn't want them to be too bright, but I wouldn't want them to be too dim either. Hopefully that makes some sense. So let's do the example now that's on 120. And this one, kind of go back to this. This is our same process that we had before with our emails. But now I've got a two-sided spec. Number of emails. And now I've got a two-sided spec. And it says, I don't want to have more than 40, but I don't want to have less than 10 either. Because if I have less than 10, then nobody loves me and they're not sending me emails. I wish. Okay. So anyway, so in this case, I don't want it to be any more than 40, but I don't want it to be any less than 10. So I'm interested in all the area in between there. That's my percent good. Make sense? Let's see how to do that in Excel stats. So it works exactly the same way. The process is exactly the same, but we're using the same data in this example, but we also have to count all the stuff that's below. So if we're going to do it in the Summaries tab, boy, that's actually not that simple. I don't know if we had maybe, well, that worked. That wasn't too bad. I've got 8% below 10 and a 7% above 10. So if I just wanted to count, that would be my answer. But let me show you how to do it using the modeling that we did before. Again, we would come up with the same picture. It's the same mean and standard deviation. We just have to do both sides. Now, luckily, Excel Stats does that for us. If you click on this Extra Tools button right here, see this little arrow right here, right there, this arrow that I just put graffiti all over. All right, we click on that arrow. It's going to take us to another one right here, and it's nice that it actually kept that, and it does two regions. So here's an interesting way to do it, or a good way to do it. You can essentially type in the first region being everything less than, and the second region being everything more than, and that'll give it to you. So for example, if I put in, not to be ridiculous, but minus 100 to 10, and then I put in 40 to, I don't know, 70 or something like that. Let me bring this in a little bit. How about 0 to 10? Oops. Even though I can't really get minus 10. What happened there? I screwed it up? I screwed it up. I screwed it up, I think. Yeah, I must have done something.
On the graph, where it says graph, okay, there you go.
Oh, it's just the graph. Yep, there you go. Just the graph. Thanks, Steve. Just the graph. So let me make it minus 10 to 70, and that ought to make the picture. And this tells me everything that's in there, and this tells me everything that's above there, and this tells me the total of those two. So this would say that I got about 6% below and about 6% above, so a total of 12%. And it's a little bit different than what we counted, which I think was 15%, but that's it. So pretty nifty and pretty straightforward tool. Like I say, you can show the values that you're putting in here, or show the probability, and that's it. So,
Mark, is there a way?
Oh yeah, sure.
Yeah. Is there a way to highlight the good, if you will? The middle versus the tails?
There actually is in this one, right? Because we could, if we wanted to, we could, let's see if we could do this. So, what if we did, now this is going to give me let's try this. Okay, and then what if I did the same one here? Now this isn't going to give me an answer that I care about, but it'll give the picture. Whoops. 10 to 40. See, I'm doing the same region twice, and that says 88% good. So that's you know what? That's another simple way to go through it. You don't add it up this time, but there you go. That's actually pretty straightforward. Oh, thanks for asking that question. I've never done it that way, but it looks like it works like a charm. Cool.
Thanks.
You bet. Okay. That's basically it, guys. That's capability. I mean, when I took this stuff, we had to learn all these crazy things that we were trying to put, into other formats. But it's pretty straightforward. There are a couple of examples there's an exercise at the back for HR. And I'm going to leave that to you. There's another exercise. There's one on one-sided and one on two-sided. So in the first one, this is a Six Sigma team in HR wanted to reduce the number of days it took to identify qualified candidates. This is a one-sided spec where they don't want it to be 60 days or more. And then in the other one, they decided, well, we don't want to do it too quickly or too long, but we don't want to do it too quickly either. And so they combined those. So that's what that is. Okay. Before we move on, what questions do you have about capability? Okay. Take a minute to write in your journals. What do you think the takeaways are of this, and what are the questions that you can ask, and how you can support business improvement? And then we will move on. Okay. All right. Let's take just a couple of minutes. Because I would be remiss to not talk to you guys about this. I have a very clear. I like just presenting capability as here's the percent good or here's the percent bad, and usually that gets the message across. Especially if you've got something where, look, 5% bad is just killing you money-wise. However, a lot of people still do like or ask you to do sigma levels, and so I want to talk through sort of what the process is to do that. And it's actually not that difficult, but it can be it can give misleading results. So I just wanted to point that all out. Okay, so essentially though, it's important to remember that process sigma is a capability measure. It says how good the process is. That's what it's supposed to be about. It does require what's called a definition of a defect, but that's not so hard. So if we recall the situation where we were looking at our the invoices or the collections last time, and we were looking at everything that was above 20 days, and I think that came out to like 29% or 30% or 26%, something like that. That would be essentially, you're saying every time we get one of those, it's a defect. All right, so let's just go to slide 135, and we'll talk about what that process is. So let's suppose we had some process, could be any process, okay, and let's say it has 4 steps in its SIPOC, or I'm sorry, 3 steps in its SIPOC. So what we want to do is we want to look at, for example, each time we send a widget through, whatever that widget is, if it's an invoice, great, it's an invoice. If it's an optical table, great, it's an optical table. If it's a phone call, great, it's a phone call. If it's an appointment, great, it's an appointment. We take a look at each of those SIPOC steps and we say, okay, how many opportunities are there for an error? Okay, for each one of those things that's coming through. Let's say it's a person who's coming through a call center process or some process. Or a pizza place. Let's say this is pizza and the first place is take your order, cook. Second one is cook it, and the third step is deliver. Okay? All right, so just to kind of make this tactical. So let's say that we looked at the process and we said, well, you know, there are 15 chances that we could make an error in the taking the order process. Okay? The second step is cooking, and there are 25 chances that we could make an error. And the third process is delivering, and there's only about 8 chances that we have to make an error for every person that we're going through and delivering a pizza to. Right? So here's my pizza guy. He's holding the pie there. Okay. It's a terrible drawing, but whatever. All right. So let's say I had then, I took a look at the last 3 months, and I had 1,000 pizzas, and I found that on the first process step, I had 29 times where I made errors. There were 500 times where I made errors in the cooking process, and there were 200 times where I made errors in the delivery process. If I look over this whole thing, I had 48 defects. I had 1,000 people that I delivered pizza to. I had 1,000 pizzas, and I had 729 defects. Okay? Hopefully that all makes some sense. Now, all that this is we start with, to do a sigma level calculation, we first calculate what are the defects per million opportunities. So that's where we start out. So the first thing is we have to calculate the number of defects. We've got that. That's 729. But now we have to look at the number of opportunities per the number of units times the number of opportunities per unit. And that's really just these things, the opportunities multiplied by, in this case, 1,000 pizzas, right? So that's what's going on right there. So it's 1,000 times 48, so 48,000. So we look at the total number of defects, divide by 48,000, multiply by 1,000,000, and that tells me the defects per million opportunities. So if I sold 1,000,000 pizzas, I would have made 15,000 defects on that. At this point, we simply use a table lookup, and that tells us what the sigma level is. It's that's the mechanics. So let's take a look at what that would be. There's a simple spreadsheet that we have in, oh, come on. There we go. There's a simple spreadsheet that I put in here called sigma level calc. And so all we have to do is kind of pop that in. And in this case, we had 1,000 units. Type that in. We had, what was it, 729 defects? Is that right, guys?
Yeah.
All right. And there's 40, each one there was 48 opportunities, right?
Yep.
So that tells me there's 15,188 defects per million opportunities. That's a sigma level of 3.67. That's it. Done. There's your sigma level if you want it, okay? So this says, at least to most people, hey, not a bad process, but it could be better. It could be, you know, we're not at 6 sigma, but we're not at 2 sigma either. Okay. So that's all well and good. But, oh, and by the way, you can also, if you look at the percentage of defects, you can do the same thing. So in this case, it was like if we put in 1 unit and 0.729, like this says, yeah, 72.9% of the time we have at least one error. That gives me the same answer, right? You see that? So you don't have to fill, you can scale it. is the point. All right, so now the Super Bowl was just a couple weeks ago. Anybody football fans? No football fans? I can't believe it.
Yeah.
Oh, okay. All right. So let me erase all this stuff. So the Super Bowl was just the other day, and let me come back to here. So, how do I lose my thing? There we go. So, oh, I know what it is there. All right. There we go. So, suppose we had a goal post here, and we have a kicker. Boy, this is terrible. Okay. Well, looks like Donald Duck. And let's say, over the course of the season, your kicker, or over the course of a couple of games, your kicker kicked these field goals, meaning that, he got 7 of them through the uprights, and he got 3 of them outside. Let's look at a sigma level for this. What might be some of the opportunities for error that this person had? What are some opportunities that this person could have made there? It could have been, let me just, what is it? It could have been a bad snap.
No. Yeah.
What else?
Block
Please.
kick.
It could be block kick. Could be block.
Wind.
It could be wind.
Bad placement of the ball.
Bad placement.
It wasn't deflated.
I'm sorry. What was that?
It was deflated.
It was deflated. Love it. Okay. And we could go on, but let's go ahead and calculate this sigma level. Oh, great. Now my thing went away. I think we had 5 reasons, right? So we had 5, oops, I'm sorry, we had 10 kicks. We had 3 defects, right? 3 of them missed. And we had, for each, there were 5 opportunities per unit. Okay? Right, let me put the picture back there. So hopefully that makes sense. So we would come up and we would say, okay, well, that gives me a sigma level of 3.05. Okay, so here's the point that I was trying to make. That is, doesn't it all seem very arbitrary to you? I mean, if you're the customer of this, right, if you're a fan of whoever it is that, notice I gave him 1 arm. There we go. If you're a fan of this team, how good is this kicker?
Average, maybe?
He's 70% good, right? He's 30% bad. So, the thing that I don't want people to get caught up on is, notice that we can always find other things that we could put here, right? I mean, we could easily, can you imagine that we could easily come up with, 10 opportunities per unit? And look what happens to the sigma level. It gets better. Jeez, I bet we could come up with 20. Oh, that makes my kicker even better. No, that's not what happens. So, when you're going through this, it's okay to do it. I'm not going to discourage people from doing it, but just remember, opportunities really need to be real opportunities, and don't ever change that goal line on how many opportunities you've got, because that's just a way to mess with people, and we don't want to do that. So, my advice would be stick to the percent good, percent bad, and that I think that tells the truth better than this can. So, anyway, that's just my opinion. Sigma level definitely has some shock value. But, if we did that, we could have easily just said there's 1 opportunity per unit, and that would show 70% good or a sigma level of 2.02. That's pretty bad. That's a pretty bad situation. Make sense? Hopefully that does. Okay. Well, I got on my soapbox for that one for sure, but hopefully you get the point on it. All right. So that's really all I wanted to cover in this. There's plenty of examples of using the tools and a couple of examples of even what I talked about there. We're going to move on, and I just did want to point out that there's a couple more sections. I don't know why I hit the going out button on that one. One in particular on probability distributions, and this one does go over, like I said, I have a video on this one, and it goes over all of the distributions that we talked about, the normal, which is the bell curve, and then these other ones, the abnormal distributions, the log normal, the exponential, and y-able. It does go through them. But the key thing is that in terms of the mechanics, they're all the same. Remember with the normal, we looked up the mean and standard deviation, then we put in our numbers for our specs, and we looked up the probability. That's how this stuff works. The slightly different ones are these, and these are for discrete variables. So these are good for, like for example, the Poisson distribution, the fish distribution here, those Francophiles. These are made for when you have where you have numbers that can occur, but you don't have anything in between. Like technically, I suppose, my email example was really one that should have been covered with the Poisson situation because I can't get 2.3 emails. However, usually it's limited where you only have a few discrete values. Poisson comes in very handy when you have something like you're looking at number of safety incidences, and you want to find, well, how many months? What's my probability that I have a month where I have more than 5 safety incidences? So that's a Poisson. Binomial is usually good when you have coin flips. So things like, I have 500 people that didn't vote in a certain county in Georgia, and I know that historically people have voted 53% for Democrats in this county. What's the probability that 300 of them will vote Democrat? Or what's the probability that 250 or more will vote Democrat? You could figure that one out by binomial. So this is usually when you have a yes or no. Binomial comes from binary. The trick with these guys right over here is that you have to be very careful of things that exactly equal things. So let me just do the example, what I mean with the Poisson. This is going to be a little bit, I'm going to give you some context. You may or may not understand the context, and that's okay if you don't. I just want to show you the mechanics of it. Now, what happened there? Did I get I thought I got it. Yeah, there it is right there. So here's my PDF. And I said Poisson was really good for safety incidences. Let's say that on average I get 3 safety incidents. And like I said, this is covered very much in that video lecture. I have 3 safety incidences on average in previous months. What's the probability that I have 5 or more safety incidences? You've got to be very careful of, is it 5 or more than 5? Because more than 5 would be 6, 7, 8, 9, 10. 5 or more would be 5, 6, 7, 8, 9, 10, etc. Okay, so you just have to be a little bit careful of that one. If we said 5 or more, it would be this one right here, 18%. If we said more than 5, it would be this one right here, 8%. Okay? So that's that. So this is used for those types of calculations. And like I say, the video goes over that pretty thoroughly. So if you want to know more, it's not required, but if you want to know more, you can. Okay. Without further ado, and I think it's a bit overdue, but it's time to get going into the week 4. So let's go into the week 4 section, and I want to spend just a little bit of time talking about, if we look at what's in week 4, like I said, putting in the agenda, erase that. I want to spend some time, very little time talking about this, a little time talking about this, and the bulk of what we've got left talking about this. So let's go to it. So if you can turn to slide 16, we'll get started on that, and I'll escape out of this. There we go. Okay. And 16, there we go. So how many of you are familiar with lean, if you've heard about lean before?
I have.
Yeah, so I said to turn to 16, but I'm actually going to thumb back a couple of slides, and this is what we're going to cover in this course on lean. So lean is about sort of it's usually the opposite type of thinking to Six Sigma. So let me tell you what that means. Let me be a little more explicit in that. So if I have a process like this, okay, this could be any process, okay, 1, 2, 3, 4. Generally speaking, Six Sigma, now this is a very gross oversimplification. What Six Sigma does is it says, let's try and identify and isolate, for example, where in this process that there's a big fire, and then I want to make this error-free, right? Remove defects. That's Six Sigma, okay? That's Six Sigma. Lean, on the other hand, says, okay, let me look at this whole timeline, and you know what? I bet that by the way, lean is also especially good if you're trying to reduce the time of something, if you're trying to reduce the cycle time or lead time. And it says, let me look at this whole process as a whole, and let me try and eliminate the waste. So Six Sigma says, let's make something better, right? Let's make it more error-free. Lean says, again, gross oversimplification, but Lean says, let's see what we can do to this whole thing. Let's look at this whole thing and make it flow better. Make it flow. Let's eliminate waste. Which means, we're removing the stuff that we really shouldn't be doing, the non-value added stuff. So here we're removing non-value added things. Here we're trying to make what we do better. Okay? Again, gross oversimplification, but there you have it. That's basically what it is in a very brief nutshell. And so, what we're going to do in this class is really talk about a few things. Come on. There we go. Today, what we want to do is we want to cover this, and I want to cover this. And on Friday, we'll cover this. Now, we're going to cover this very quickly, so any reading that you can do beforehand would be good. In the end of the class, we'll do more advanced lean, and this is sort of a combination. This is very similar to something, for those of you who know, called operations research. I'm drawing a blank on this on the name of the movie, but there's a movie that's out there. It's up for the Academy Award, and it's about Turing, Alan Turing. Has anybody seen that one? Time of something? No? All right.
Theory of everything?
No, not Theory of Everything. It's the other one. Oh, maybe it's not up for Academy Award. Theory of Everything is about Stephen Hawking, right?
Stephen Hawking, yeah.
Yeah, no, this one is, it's about Alan Turing in Bletchley Park and all the work that he did. He was a guy who kind of invented, along with John von Neumann, the digital computer. And in the 40s, his brilliant mind, and he really saved the bacon of a lot of people in World War II because he developed a lot of things that eventually helped to crack the Enigma code. But anyway, just a brilliant mind. He kind of invented or he, along with the others there, invented the discipline of operations research, and that's what this stuff is all about. It's sort of like adding hard tools into the soft tools of lean, things like queuing analysis or what we call constrained optimization or linear programming, process simulation. All of those things you can consider to be part of lean as well. So we'll cover those at the end of the class, not now. So let's talk about metrics first, and I'm going to erase all this stuff. Let's talk about metrics first, and that begins on slide 16. And I don't want to talk too much about this one, but I want to stay here, which I think is slide 16. Sorry, 17. Slide 17, I believe. Come through. Yes, slide 17. And I did want to mention, I'm just going to mention, I'd like you to read through this section, and I want you to pay particular attention to these right here, okay? Because these right here are going to be some things that we will, there's an exercise that we do, and it shows you kind of how to look at, these all help you really manage capacity better. So very often you can look at these metrics right here, like for example takt time. Takt time, it comes from, actually most of these things come from Japan, but this one comes from German. Takt is a baton in German. It's kind of what a conductor would beat with, and so it kind of manages out sort of like what's the tick-tock of your manufacturing process or of your operations process. So it says kind of like how it beats or how it should be beating. Lead time kind of measures real time or elapsed time between the beginning and the end, and cycle time is kind of like it tends to be more inward directed. I know that people can define them in different ways, but cycle time tends to be more inward directive, and so you're looking at sort of touch times, things like that. Finally, exit rate or throughput says how many things do I complete per day, or how many things do I kind of spit out of my process per day or per hour or per minute or per second. And you can use all these things together to look at how capacity is moving through, or how things are moving through your process, and to manage capacity better, or to be able to understand whether things like load balancing will work. So that's there. These others here I think will present you with no issues whatsoever. You may not have heard of rolled throughput yield, but it's something that I think once you see it, you'll know exactly what it is. On-time deliveries are pretty straightforward. So, so I do want to show you, so we'll talk about these in the beginning of the next lecture for sure, but I want to have you get a chance to look through it. And then I want to show you rolled throughput yield right now, and that is on slide, oh goodness, I can't see the slide number. Well, it is on slide, oh goodness gracious, it's on slide 26 if you're following along. So rolled throughput yield is essentially just the percentage of stuff that you take your process, again like at SIPOC level, and at each process step you map out the percentage of things that get through the first time 100% right. So let's say I had invoices, or let's say I had my pizzas again. I had 5 steps instead of 3 steps before. First step might be take the order. Second step might be translate that order to the kitchen. Third step might be cook the pizza. Fourth step might be put it in a box. Fifth step might be deliver it. Okay? So the first step is take the order. This would say that out of 100, let's say I had 100 orders and 98 of them were done correctly, and I didn't have to rework them. I didn't have to do anything. I didn't have to change them. They were correct, and I didn't have to change them. Then my rolled throughput, or my percentage there would be 98%. Step 2 would be transferring it to the kitchen. Let's say, you know, on 89 of them, the kitchen didn't have to come back and they were right, but on 11 of them, they were either wrong orders, or the kitchen came back and said, Mark, what did you write here? Or, you know, does this say pepperoni? I think you get the picture. This is anything that gets reworked or is wrong. That's the opposite of that, yeah. So 89% would mean 89% of the stuff doesn't need to be reworked at all, and it's correct. And so forth. And, you know, putting it together, you end up with a number that's usually fairly low. And it can be a good shock metric to say, this is the amount of stuff. This is how much extra labor and work and sort of waste, useless work that we're doing. And I can tell you that at one of the companies that I worked, it was a Northeast insurer, and we looked at the rolled throughput yield of getting provider data, that's the doctor's data, in correctly, and loading it through like 3 or 4 steps. So loading provider data. And that's important because when you go to the doctor and you fill out the insurance card or whatever, the doctor sends to the insurance company the paperwork, and the insurance company reimburses. They could reimburse incorrectly or they could reimburse correctly. It may vary by state or who's in there. So getting getting the details right is pretty important. But I'd like you to guess, what percentage or what was their rolled throughput yield on that process of the provider data load? Tammy, what would you guess? I'm asking Tammy because I know she's in the biz. What would be your guess?
Well, I'm really which piece though. I'm confused, I guess.
On loading so each month they had to load the provider file. So they get this data from all providers, and they're trying to look at the rolled throughput yield, which was the percentage of times they never had to rework and they got it correct.
Oh, never? Oh, maybe 50%. Maybe 50%.
Yeah, it was 7%. So 7% of the time they didn't have to. They either got it right or didn't have to rework it. So it was incredibly shocking. They were just astounded that they said, "Really, it's only 7% of the time this stuff works the way it's supposed to." And over the course of the year, they were able to get it up to like 70%. So it can have a lot of shock value. That's the good side. The bad side is it's very difficult to measure, right? Because you've got to measure different process steps, and you've got to look at how much good stuff is coming in. You've got to look at how much rework is there. So it's definitely very difficult to measure. So there's some good stuff, and there's some good side, and there's some bad side to it. Anyway, I wanted to share that with you. I don't think it's necessarily it's very similar to first pass yield. It's a metric that I wanted to show it to you. Some people really like it. Some people say, yeah, it's going to be too difficult to measure. I'm going to move on .org. All right. Remember, we'll have a full discussion on the time metrics next time around, but I'd like you to, this is kind of an assignment for next time. I'd like you to go ahead and read this. Okay. We'll go over this exercise next time. This is in your homework, but I do want to go over it because it's a difficult one, and people have had questions about it. And I also think it's an important one because it's meant to illustrate the whole where should you work on, and using a combination of those metrics, the tack time, the lead time, the cycle time, the exit rate, all that kind of stuff, to be able to understand why is sales going down? What's happening here? So it's a real good, I think it's a good illustration of, yeah, you can look at a process and understand what you're doing well, what you're not doing well, and how you may be misusing capacity. So we'll go over this fully next time. Well, I want to go over it full enough for you to do the problem yourself so that you get it. Okay. At this point, I do want to talk a little bit about the nuts and bolts lean tools, and then maybe I think we'll have some time to do the team tools, to do an exercise. So in the nuts and bolts lean tools, we're going to talk about, these are real workhorses of lean. One is called a value stream map. One is called process analysis. Now, it's a pretty generic name. One is called the waste walk, or 7 wastes. And one is called the 5S. Looks like 5-5 or SS. It's 5S. Okay? And all of these are really helpful, particularly these last two are really simple and powerful. So I want to emphasize those. Okay? So let's go through these, and whatever questions you have, don't be shy about asking them, because especially with the value stream map, we'll save the best for last. We'll do the most difficult one first. The most difficult thing is the value stream map. At this point, all I really want us to be able to do is read it, read a value stream map. So that's what we're going to be doing. Okay. So let's head into the value stream map. Remember that this is all about identifying waste. So lean tools are about being able to visualize that waste. They're all about making you see the waste. Okay, the first thing is the value stream map, and let's just walk into it whole hog. Here's some instructions on how to do it, but let's just take a look at a picture. This is a value stream map. Oh my God, it looks really complicated, and it sort of is, but sort of isn't. So let me break down what this is. Some people like to call this a process map on steroids, but it's really not that bad. What it really is in this case, by the way, value stream maps can be done at a high level, that means sort of SciPoc level, or they can be done at a detailed level. If you're going to do a detailed level, a value stream map is a huge undertaking, so just be aware of that. I would advise, if you're going to do a value stream map, by the way, not recommended for every black belt project, and I'm not recommending it to your situation right now. However, a value stream map, if we talk about it and we're doing some consulting and I find, or a consultation, and I find a value stream map may help, I can help you work through it, okay? Right now it's just familiarity. So I want us to be able to read it. Let's think about this as a sort of a SciPoc level, high level. Let's break down what's here. First case, this is showing customer to customer. Usually there's customer to customer. So this is a customer here and a customer here. The idea is you're usually putting receipt to order to receipt, sorry, or order to cash, or whatever it is. Whatever that is. So it's very big picture. Okay? So this shows usually you start with the middle here. These are the process steps. So here we've got step 1, 2, 3, 4, 5, 6. Okay? So there's 6 process steps right here. Second thing that goes on here is you usually show a supplier, or who's supplying the order, and who's getting it, right? So those are these things right there. Third thing is you usually give some data on each one of these things. So let's take a look at what the data are for this. Usually there's a box underneath it, and this thing right here is called a Hayunka box. I'm not going to spell this right. I know that's not very helpful, but that's what it's called. How about calling it a data box, guys? Makes sense to me. Let's call it a data box. This usually gives, this can be anything, but here in this case it's giving cycle time, batch size, how many we're sending through, uptime, this is usually like an IT measurement, and a quality measurement. So this IGO in this case, this happens to be for a life insurer or a financial services company, and they have something called in good order, or IGO. So this tells me sort of percent good. So this maybe tells me a defect rate and all that kind of stuff. So it tells me cycle time, batch size, uptime. That's pretty typical, but those can change. The other thing it shows me is inventories. So it helps me understand where buildups are and all that. So far, so good. It's getting pretty complicated at this point, isn't it? Another thing it shows me is a timeline. So it shows a timeline on the bottom, for example, and this one's hard to read because it's not in the picture. So right away you see that this is 1.5 days, this is 3.5 days, this is 1.5 days, and some of these others are in minutes. What the steps are, and there's no standardization on this one, is usually the tops are delays, or sometimes the tops are delays and the bottoms are actual processing time. So there you go, and that's what it gives over there. So it tries to give you a difference between that. So you see the lead time versus the processing time. Here the lead time is 28.5 days. That's how long it takes us to process whatever these are. Let's say they're life insurance quotes. 28 days, but really we only work on it 199 seconds. Seconds? How about minutes? That looks like minutes to me. Okay, so whoever did this one, shame on them. Okay. One final thing that it shows. Oh yeah, and by the way, it also shows usually some of those some of the timing there. Sometimes it shows some central control, sometimes not. Okay, but it shows some flow. So it usually shows some flow control. Okay, so tons of things on this. It really is a process map on steroids, isn't it? Okay, so what do you use all this stuff for? I'm going to get rid of all of my red here now. What do you use all this stuff for? Well, I can. For example, I can see if I'm going to, by the way, you do one for an as-is, and then you do a 2D. Okay? All right, so usually it's done first as an as-is, and then you look for where you might improve. Remember, we're looking for lean, so we're going to try and get rid of big things like big delays. 20-day delay, that looks like something I want to do something about, right? A buildup of 2,000 in inventory, that's a lot bigger than these others, so maybe that means something. If I look at quality, this is a low quality, this is low quality. So I can look at things like that. And I can also, as we'll find later when we look at lean solutions, I can also look at central control and flow. So notice how these are directional arrows going this way. Sometimes in a process map, and I'll show you on the next one, it'll show, this is a highly controlled process, right? Some central planner is telling everybody what to do and coordinating things. And so when we talk about lean solutions next time, we'll talk about how that's kind of a no-no, and you want it to be a pull. Pull is usually written by an arrow that kind of is a circular thing. You'll see it in just a second. But anyway, those are the things I think that we're probably going to want to try and improve. We're going to want to do something about this this inventory. We're going to do something maybe about some of the quality. We're definitely going to do something about these delays, maybe here and here. And we're probably going to be doing something about the flow. So let's take a look at what they decided in the 2B. Oops. Okay. So this is kind of showing as it is, and the 2B, well, it's very similar to the improvements here that we had. So there it is. So instead of having, I guess this is going from production to, we've changed our example, but here we're looking to where these little lightning bolts are, or the bursts. Those are called Kaizen bursts in the business. Kaizen bursts, which just means we're going to do something about it. So here they're going to change the flow. You see how these are pulls now instead of pushes? Okay. We're going to do something about, I guess, the inventory and so forth. You notice how, whoops, let me erase this one. If you look at this, the Kaizen bursts here are where there's the big delays. Now, I don't know what they're doing about this 10 delays, but I would do something about that. But it looks like they're doing something about that. Oh, 90 pounds of whatever. Okay. I might, if I were in the previous one, I might go to this and say, for this one, I would say, and my Kaizen burst is going to be terrible. Well, I might say this is exactly what I'm going to work at. I'm going to work at the quality on this step, the quality on this step, the quality, or look into the inventory and the delay right there, and maybe look into having some of the central control move to these guys pulling from each other as opposed to having to be controlled by some central planner. So that's it. Those are just guesses, but the value stream map is going to be helpful at reading through there. Again, I think if we look through that, we can look and we can break it down by saying at the bottom is timing, then we've got some process data, we've got our queue data, we've got our scheduling and coordination right there, and then the process steps are all right there. That's our process steps right there. Okay? So it's a process map. Okay, I'm going to stop here for just a second and ask, what questions do you have on value stream? Because it does look like kind of a complicated mess. Okie doke. So we're going to move on.
I don't have a question.
Oh, go ahead.
Sorry, I was going to say I don't have a question. I was just going to say I'm glad you're not recommending it for our project.
Right. So if you see it, you'll know how to break it down, and you know what the phone number is to call. You have my number. You say, help or whatever. But yeah, and realize we went very quickly on this. It's really just exposure to this for sure. Okay. Here are just here's a review of some of the symbols. Okay. Let's walk to the next one, which is a waste walk. Really simple tool. And think about it this way. This is just like a clipboard that you've got that has a bunch of things that are going to jog your memory of areas or of different wastes that can occur in your process. Okay? So in the old days when I worked at Corning, I would do this. I would take a clipboard and I would have categories like this: transportation, inventory, motion, waiting, overproduction, overprocessing, defects. Tim Wood. See that? Tim Wood. That's the acronym. And I would look at a process and I would write down the things that I thought, I wonder if there's transportation waste here. I wonder if there's inventory waste. Now the key thing here, so you can do this either for real, by walking out on your floor, and if you're doing looking at waste in the office or on the manufacturing floor with the optical tables, or you can do it virtually as well. There's no reason to not be able to do this. Now the key thing to this is in a lot of cases it doesn't matter where you categorize something. These are just to help jog your memory to say, oh, that's a waste. Oh, maybe I could eliminate that. That's all it is, right? So, for example, let's go through what examples of these might be. So, transportation waste. An example might be at I did some consulting at Schweitzer Aircraft years ago, and they were moving helicopters all over their plant floor. That's transportation waste, right? If they can eliminate a lot of the movement, they don't have to be shipping moving forklifts and shipping this thing all over the place within their plant. So that's an example of transportation waste. Lots of other examples though as well. Inventory, I think we all know what that is. Or if we have real goods inventory, or it could be even inventories of emails that are building up in your inbox, right? That causes waste because it causes time that you have to spend. Motion. So what's as distinct from this one is here I think of this as people. So this is, I'm looking at people moving around unnecessarily. Waiting, these are delays, right? Anywhere where there's delays. If I'm waiting for somebody to move out of the way to move forward, if I'm looking at a kitchen, or if I'm waiting for a transaction to be finished, or waiting for a computer program to run before I move on. Those are all delays. Again, we're not saying that we can remove all of these, but the key is to notice them first. Overproduction, these are things that we're making finished inventory. For example, maybe we're printing up excess reports that nobody reads, or maybe we're printing up extra marketing materials that then become obsolete. That's overproduction. Overprocessing might be we're checking things that don't need to be checked. We're checking the checkers, or whatever. We can overprocess things. And then finally defects, and we all know what those are. Things that we're doing wrong or reworking. Let me give you some examples. So this really is a very active thing. You can go out and do it. Okay, let's do some examples in here. For example, in an office, and then a classic example. In transportation, a classic example would be movement of material goods. In an office, it might be too many approvals, right? If I have a sheet of paper that has to go from, to 16 individuals, that's going to cause a lot of delays. Okay? Now, notice I said that's going to cause a lot of delays. So could I have put this in waiting? You bet I could have, and it doesn't matter. All I want to do is capture it, right? I don't care how I categorize it. All I want to do is capture it. Okay, inventory, excess marketing materials, excess report. Geez, I just used those exact examples, didn't I? But it could be, in classic, it could be, more work in progress than we need, more raw materials or finished goods. Motion might be poor employee layout, but in the office it might be walking from cubicle to cubicle. Recently we just saved the company. It wasn't a big win, but it was a small win. We estimated it was about $15,000 just by purchasing an additional fax machine. The person who's doing all the travel for a number of people was spending an immense amount of time simply walking around the office to go to a fax machine and waiting for a fax machine. Okay, I think you get this. So I'm just going to ask, what questions do you have before we move on?
Mike, this is Steve. In
Yep.
this exercise, do you try to quantify the amount, or you just want to note it?
No, I'm just noting it. I can write some notes. If I want to try and quantify it or put a circle around it, that's great. But this is really just for identification purposes. But you could jazz up the tool if you wanted to by putting some measurements on it. There's nothing that says you can't do that. But the classic tool is to just have a clipboard, and you're just saying, okay, there's a waste. I'm going to write down what that is, so that next time I can show the rest of my team what's going on. Good question.
Okay, thank you.
Good question. What other questions do you have? Okay. All right, let's move on to process analysis, and this one's a little more complex, and I don't want us to freak out. So don't. How about that? So in this case, what you want to do is, I'm going to go back for just a second to here. All right, unlike this one, which I recommended you not do during your first project. Okay, but B, I said, this is a high-level process. The process analysis is for a very, very specific process, right? Here's where we might do process analysis. No way would we want to do process analysis on a huge process, okay? Just wouldn't want to do it. So to put this kind of in the context of the pizza, this would be something like, if here we had the 5 steps, right, where the middle one was cook, it wouldn't even be on cook. It might be, cook might be put on ingredients, put ingredients on, and then put in oven. We're talking about at this level, really detailed. All right? You can open it up maybe to the whole cooking process, I guess. You could probably do it that way, but I hope you get the picture. Do this on a detailed area, not a general area. Otherwise, it'll drive you crazy. Okay, so here's what it is. You basically list out all the micro steps of the process, and what you do is you include 5 different things, right? So you're including as part of the process not only the process step itself, which is written by a oval, or not an oval, a circle, but also anytime there's any transportation, you write down that as an explicit step. Anytime there's any inspection, you select that, for example, step 5 here is meant as inspection. You select that little icon and you write down what that step is. Anytime there's any delay, whether you have to, and if somebody waits for something, you write that down and you put that symbol in. And anytime there's any storage, you put that symbol down, and that's that. And then what you can do is you can, if you want to, that's fine. Let's just look at the left-hand side here for a second, and we can already see what we've done is we've eliminated a lot of the waste in the process. Why is that? Well, the process steps are really these guys right here, right? Just those. Mm-hmm. And just looking at that, out of the 15 steps, we've only got 3 that are really just process steps. The rest are either transportation, inspections, delays, or storage. And those are arguably all non-value added. Now, that would be enough, and that can tell you, again, visually, I think very quickly you can see where a lot of waste is. So just if you do that, there's a lot of value in this particular tool. However, this one can be jazzed up a bit if you do 2 things. One is if you put time in there, how long did this particular thing take? So for example, this took 1.25, let's say it was minutes, whereas this particular process step doing it only took 30.3 minutes, and this one took 0.1 minute, and this one right here, then there was a delay of 2.5 minutes. So this can also tell us sort of where to focus on as well. And then finally what we've done is we've jazzed it up and we've put it into 3 buckets: value added, non-value added, or this third one, which has never been my favorite, business required, non-value added. So let's talk a little bit about what those are. I'm going to give you the classical definition of value added, and then I'll give you a practical one. So the classical definition is, and this is what I was taught, and it's kind of BS. The classical definition of value added is anything the customer would pay for. Well, I think nowadays, many of the things, I mean, for example, in a lot of cases, you would talk about, like let's say, any technology. Unless it's really transforming that product, if it's just moving information around, you might even say, well, the customer wouldn't pay for this. Well, sort of. I mean, to a certain extent, that's required to even be in the game. So I think that's one of the reasons why this business required non-value added came up. Instead, I like to think of, instead of using that definition, I like to say value added is anything that fundamentally changes changes the form, fit, or function of your widget. Okay, the 3 F's there, the form, fit, or function of your widget. So if you're making optical tables, and optical tables, I don't know, I'm going to take a guess, but my guess is that they need to be really stable. They're stable pieces of metal, and you need to drill holes in them to be able to put optical equipment. Those holes being drilled in are value added because the customer is not going to buy it without without that piece of sheet metal being worked that way. So that's got to be value added. Okay. Now the difference between non-value added and business required non-value added might be something like compliance. So for example, now I actually think that there's some value added in HIPAA, but a lot of people in the business would say HIPAA, the Privacy Act, a lot of people would say that a lot of the compliance that people do is non-value added, that companies do is non-value added because customers really don't care all that much about it anyway, and we spend a lot of time doing it. So take that for, that might be either business required non-value added, or it might be non-value added, wherever you want to put that. But non-value added really would be, it's just pure waste. We don't need to be doing this. Nobody cares about it. Can we please just stop doing it? Delays, there's no value at all in a delay. That's got to be non-value added for the most part. Okay? Questions on this one? Okay, there are no questions. However, what I want to do is I want to take a minute to make sure that you see that they're in. I want to make sure that they're either in the tools or the okay, they're in the templates. And now I'm going to be oh, no, I thought I was going to be made a liar. In here there's the one that says, the confusing thing is, I just noticed this today, the one that says blank actually has an example in there. Okay? So, and the one that says example doesn't really have anything in there. But you can see that all this is there are a bunch of different things in that you can type in what you want. You can type in the times. So for example, this is a business required non-value added. If I make it bigger, like say 100 minutes, you'll see that yellow box go up. There, it went up a little bit. And if you change that to value added or whatever, you'll see that changes around all that stuff. Okay, so there's a little thing in here that you can use to hopefully help you out a little bit. Okay, let's finish up this last one with a 5S, which is one of my favorite tools. I'm just going to tell you about it right now because it's really pretty simple. And I have to ask the question, Steve, were you referring to this on your assignment when you said implementation?
I did.
Yeah.
I did, and I said 6S, and you asked, so is safety the sixth one, and it is.
Okay, good. Yeah, so the last one was
one.
safety, right? Yeah.
Yeah.
Got it.
I've heard there's more than 6.
Yeah, yeah, yeah. Well, the original five work wonders, and I think in a lot of places, like hospitals, they're adding this sixth one too, and it doesn't really fit in the paradigm. So for what we're going to call today, I don't mind anybody adding it. It's good to add, but for today, we're just going to consider it without it. What is this? Well, a 5S is a tool for systematically organizing and maintaining a clear, efficient work area. So high level, think about your garage. I actually 5S'd my office because it was long overdue last weekend. And I'll tell you, the amount of work that I'm getting done this week is much better. So here's how it works. If you think about your garage or your basement or your kitchen, whatever is the messiest place that you've got, okay? So what do you do, or if you've ever watched that show Hoarders, I cannot watch it. I watched half of one once and it creeped me out too much. I cannot watch that show. But if that's for you, then this should probably work. The first thing you do is you sort. And that means I take all the stuff that I don't want to keep and I throw it out. And I take all the stuff that I want to keep and I basically build 2 piles, throw out and keep. Okay? Now some people build 3 piles, throw out, keep, and maybe. What's the problem with that?
You probably don't need it.
You know, that's probably you don't need it, but where does everything end up?
Back in
pile.
Yeah. Everything ends up in the maybe pile, so it's not usually very helpful. So if teams want to do that, I'm okay with that. They start out, and then I usually say, okay, now we got to deal with the maybe pile. It goes in the keep or the get rid of. By the way, we're just introducing this tool. There's lots of other things behind it, but anyway, that's the first thing. Now that you've decided what you're going to keep and what you're going to throw out, you throw out, essentially just functionally think of it this way. You throw out the stuff or recycle the stuff that you're not going to keep. The stuff that you are going to keep, you set in order. What does that mean? That means that means that you have to find a place for everything that you're going to keep. All right. So if you're doing your garage and you say, okay, I'm keeping this basketball, I have to have a place where I keep the basketballs. Make sense? And it's again, this isn't rocket science or brain surgery or rocket surgery. It's this is pretty straightforward. It's hard to do because it's emotionally difficult. Okay, the third thing you do is shine. So once you get all this done, you clean the area. That happens a lot, right? You're cleaning something and you're like, oh my God, I can't believe how dusty it was behind all these shelves. Or, oh my gosh, I'm cleaning my garage, I found a dead mouse in the corner. Sorry for grossing everybody out. Or whatever, right? So it allows you to clean in areas that you haven't cleaned in a while, and that further puts emotional baggage on you to dirty it up again. So it helps a little bit there. Now, everybody's good, or many people are good at 3S. Not everybody's good at 5S. 5S, and this is where companies often stumble. 3S is good to get going, but to keep it going, you have to do the next two. So the next one is standardize. It's not just me cleaning my garage and making sure that the basketballs get in the right place. It's my daughter, it's my son, it's my wife, everybody. Here's where all the fishing equipment goes. Here's where the basketballs go. Here's where the ladders go, etc. And then finally, sustain. And this is really, sustain, it's really about monitoring. Just making sure that we're on plan. So we're going to standardize. Are we actually doing it? So go back, in a week to say, are the basketballs where they're supposed to be? And maybe have my daughter audit that once, and my son audit it once, and I'll audit it once, and so forth. By the way, I don't really do this to inflict my family with all of these things. Not without their knowing it anyway. All right. So that's it. That's a 5S. Let me show you a picture of where it might be done in manufacturing. So here are some good practices. So it's to make it visual, right? So here's an example of, we've got the broom put within here, this tape box. Whatever this is, looks like a metal shavings bucket or something like that put there, or dust bucket. It looks like something's missing from there, but maybe that's, that lets us know what's out, what's in. There's some color coding going on right there. There's the old tool silhouette. I've got one of those in my basement, and they're all empty. But Grandpa had one that was all full, and it worked for him. Okay, and you can tell at a glance what's there and what needs to be cleaned and so forth. Let me see if I can find an example. Oh, I didn't give an example. Let me see. I'll give you an example on my. I'll try and give you an example. Maybe I'll be called to task on this one. I'm going to give you an example of. Okay, so it's not that good anymore, but I really work hard to keep my desktop fairly clean. You can see I've got a couple of things that are still in progress there. And I've got my black belt stuff out just for today's lecture, and some things I'm working on. But when I'm good, I've got everything going into my temp file, and then I've got a process where I go into my temp file, and after a certain amount of time, if it's there, I have to do something about it. I have to move it into a permanent file, or I throw it out and get rid of it. So that helps.
Is that your maybe folder?
What is this? This one is my maybe folder. That's right. You got it. That's my maybe.
Hey, Mark. John and I have to drop off like
Okay.
1 minute to 1. Just FYI.
Okay. Yeah. And no, thanks for telling me. And we're basically done for today. We're not going to keep going. But I just wanted to ask, where before we finish up, where might else you be able to use this? Where might you be able to use 5S? At your in your personal work or at your workplace? Students able. Well, everybody knows we've got, in every office, we've got that one office where we put all the old used furniture and all that stuff, and the books, and we really need to clean that one off and have some guidance on, you know, how we're storing stuff and what we get rid of and keeping that clean. That's one example that I think everybody, or I'm used to seeing that. Where else might you use it?
Like the supply room, perhaps?
Supply rooms are perfect. Yeah, it's a perfect example. How do we take tools? How do we put tools away? How do we take supplies that we're going to be using, like pens and paper and stuff like that? You don't have to go nuts on this stuff, right? But sometimes you walk in and the maintenance rooms are just shockingly ridiculous. You know that there's a lot of wasted time there. Where else? How about with computer files and stuff? Do you think that maybe there are places where you could 5S SharePoints or shared drives or things like that? Okay, I'm
absolutely. Yeah, absolutely. I mean, I'm guilty of that too. I think we're all using a lot of space on computers than we realize.
Right.
Because we don't go back and empty stuff out.
Right. I'm going to give you one more, and this hopefully will ring true, and that is your inbox. How about your inbox? Now, this is a personal thing. Do you think that you waste a lot of time looking at, you know, way too many or wading through way too many emails? And if you could 5S your emails and keep that and tame that a little bit. There's a program called, not a program, a mindset and a process called Inbox Zero. A lot of people used to follow. I still follow it, and it helps to keep, I'll see if I'm going to make myself a liar again. I know with my personal account it's that way, but my business account, okay, I'm a bit of a liar because I just switched. And I've got lots of stuff from today, but I'm on, by tonight, I can see that Tammy emailed me, which is great. By tonight, I will have this. By tonight, I will have this on a single page, and I'll be able to read all my emails and know what's there. And that's really just using 5S. So anyway, lots of stuff. We'll illustrate that next time by doing a little exercise. But I think at this point, I would like to stop now. We've finished this section, so you're all set to write this out. Remember, for next time, I'd like you to read those sections in Lean, the first section and the section on metrics. I think that's going to help a lot. And it will also help a lot if you look through the section on team tools. You can just kind of flip through it and see what's there. Okay, guys, we'll see you on Friday, and thanks a lot for your time. I appreciate it.
Thank you.